last example of Lewis structure drawing that we're going to see is for this bromate ion. It's a polyatomic ion, but it is held together by covalent bonds, so we can still draw a Lewis structure for such an ion. The only difference between drawing a Lewis structure for a polyatomic ion and a neutral covalent molecule is that we have to include the number of electrons associated with the charge. Remember, if something has a negative charge, that means it's gained that number of electrons to acquire that charge. And if it has a positive charge, it's lost that number of electrons to acquire the positive charge. First, as always, I'm going to determine my central atom. It's going to be Br in this case. Because there's only one Br, it's written first. That's the best choice. Secondly, I'm going to add up the total number of valence electrons. Br is in group 7a, so it has a total of 7 valence electrons. Oxygen is in group 6a, so it has a total of 6 electrons per atom. But I see a subscript of 3, so that means that I've got 6 times 3 electrons coming from the 3 oxygens. And then, because I see this -1 charge, that tells me that my group overall has an additional 1 electron. If it was -2, it would be +2 electrons, -3 +3 electrons, and so forth. So I add up my total, as before, 7 plus 6 times 3, which is 18, plus 1 gives me a total of 26 valence electrons to show in my drawing. So I start off my drawing by putting my central atom down in the center and then attaching the terminal atoms, the 3 oxygens, to the central atom with single bonds. So I draw my 3 oxygens attached with 1 dash apiece to the bromine. Again, I've got 26 electrons that I can distribute. I need to show a complete octet for each atom, and if I run out of electrons, that's when I would do a double bond. So I can start with one of the terminal atoms. I'm just going to start with the oxygen on the left, but you can start with whichever one you'd like. And currently I've got 6 electrons shown in the drawing, so I've got 20 more to distribute to the rest of the atoms. So the oxygen on the left already has 2 electrons. I'm going to add 6 more electrons for a total of 8. Then I'm going to move on to the oxygen on the bottom. I'm going to give it 6 more electrons for a total of 8. If I count up how many electrons I've used so far, 2, 4, 6, 8, 10, 12, 14, 16, 18. So I've got 18 electrons shown so far. I need to draw 8 more on for my drawing to be complete. So I move on to the third oxygen, give it an additional 6 electrons. So that now gives me a total of 24 electrons shown in the picture. The oxygens all now have a complete octet. Notice that they have 4 lines in contact with them on each side, which is 2 electrons apiece. But the bromine in the center only has 3 lines in contact with it right now. So the last 2 electrons can belong just to bromine by itself. Should always go back and double check my work, count up the total number of valence electrons. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. So there are 26 valence electrons shown. I also have 8 electrons in contact with each of the atoms. So this oxygen has 4 lines around it, so that's 8 electrons. This oxygen has 4 lines around it, 8 electrons. This oxygen has 4 lines touching it, 8 electrons, and the bromine in the center also has 4 lines touching it, and so that is 8 electrons. So my drawing is finished if everybody has a complete octet of electrons, and I've got the correct total number of electrons, which is 26 for this drawing. The only other thing, if we have a polyatomic ion, is that we need to indicate what the charge is of this group together. If we don't show what the charge is, then it will not be clear how we got 26 electrons instead of 25. So all you need to do is put brackets around the whole molecule once you're finished drawing it, and then put the negative sign or whatever the charge is on the upper right-hand corner of the brackets. Now my drawing is complete.